Oh, my bad.
Wait, you were calling me?
Yes, because like my parents were like, what's
Okay.
happening? And I was like, I'm not sure if I joined the right one.
Okay.
So I just called you.
How's everything? I had my there was another client that went overtime, but let me try to share my screen. There's like, did you get my email by chance?
Yeah.
Okay. Let me see. And so I heard you guys will, or actually I heard you did pretty great on your previous exam.
Yeah.
Yeah, how did that go? Like, how was the problems, I guess, if you remember?
It was okay. Actually, it was good. I know I only got one wrong, but I know what I got wrong.
Okay, that's good. One wrong. Wow, that's a good. That's really good. And then this next exam is this Friday, right?
Yes.
Okay. From what I got from your teacher, it's not really that bad. How do you feel about Trig identities?
It's pretty good. I wasn't there for a day though, so for 2 days, so I had to like learn it all pretty fast. But I mean, we took a quiz today and I pretty much understood it. Actually, I'm gonna check real quick if what I got,
Okay.
whether or not that I was
Let
right.
me know what you got. Yeah, so we can maybe, because I know I have you today and Wednesday.
Oh, she didn't put it in.
Oh, okay.
So you have me today and Wednesday?
Yeah, that's what I got like
Okay.
on the schedule. So let's take a look at like I guess what do you have like problems on if anything with track identities? This is what I got from your teacher. This is all
Yeah.
the
She says that we need to memorize the even odd, the Pythagorean
okay.
theorem, the quotient identities, and the reciprocal identities.
Okay. What about is she gonna give you the other ones?
No.
So you have to memorize the other ones as well. Then these half angle
No.
ones.
No.
Oh, it won't be in the test.
No, it'll only be those 4.
Oh, okay. That's not bad. And then in terms of like quiz problems, what do you remember what they were?
Yeah. Okay, so we're doing like the inverse circle thingy, so it's like the unit circle, but
Oh, okay.
it's like
And we
one
see.
half square root of 3/2, and like square root of 2/2, one half square root of 3/2, and then like the
I think
tangent.
I got the same thing. Is it this guy?
Yeah. Yeah, and okay, yeah. That's the
Yeah, this is the one that she sent me. So I was like,
Wow, she's sending you the quizzes.
yeah, they all done. I'm VIP. I don't know if the answers are here though. Let me
Yeah,
see.
no.
Oh, we can cover like so like if you look at this guy, how did you do or how did you feel about this?
It was okay. I didn't get number 20. Wait, can we go over it so I know if I did it right?
Okay, so what you should do with like for example this guy. I don't have my iPad to this. That's why I'm doing this.
I think it was like pi over 6, right? Oh no.
Yeah. How did you get that one though? Like tell me how you got that. And like because the way you remember when we talked about unit circles before, like the way I usually do it is like this I would do the triangles and then
Actually,
like
I think it might be pi over 3. Wait. Yeah, I think it might be pi over 3.
because this is cosine, so it's adjacent, so it would be right here, right?
I just have it. I just memorized the thing.
Yeah. Okay, if you memorize it, that's good. So if pi over 3 would be this guy, like this angle right here, because after you do like this triangle, 1/1/2, and then like let me see.
Dang, then I put the wrong thing. I switched it.
You switched it?
I switched it.
Let me just check if I.
Pain.
Let me check. Because that's the way I would do it. So cosine, arc cosine. Arc cosine 1/2. And what is that? They always give it to you in rad. In degrees. Did you get 60 degrees? 5/3?
Yeah, well, I switched it. I did like I think I switched it on the test, but on the quiz, but that's because I was stressed, but I know what it is actually.
Okay. The thing is, like I said, when you memorize things, it's like a drop of a, like every time you're when you're stressed, when you memorize things, you tend to forget it. But
Yeah.
if you do it this way, like there's a system.
Yeah.
Because you know how, but do you understand how I do it this way though? Because like you have this one half, right? And you create these 30, 60 triangles or like 45, 45, 90. So like, and what is cosine? Cosine is what? Ka, right? Uh, like adjacent over hypotenuse, right? So SOHCAHTOA. So you do one here and then one, like two here. And then what is this angle? Like by what you've learned already, it's pi over 3 because it's across this guy. It's not
Mhm.
across this guy. Yeah.
Yeah, but I don't really think I'd probably use that because we don't really
Okay.
have time. Quizzes.
So
It's like
you would just memorize it
we have like 5 minutes.
for the quiz.
Yeah.
Oh wow! Like all of this.
No, well, it's like 5 minutes per. It's like we get 10 minutes, so it's like I have 5 minutes for the front, 5 minutes for the back.
Okay. Yeah, if you memorize it, I mean, it's not bad. As long as it works and like make it natural, obviously, because so that when
Yeah.
you're stressed, then you know it or you still know it. So okay, I guess for this one, if you take a look at this guy, let's see, it's not in degrees. What did you get for this one? Negative 90.
Um. Yeah, but you would put that in radian.
So negative pi over 2.
Yeah. Uh. Pi- oh, yeah.
So let's see. For this one, if it's
No. I think whenever it's doing that, it's not talking about I thought when it's like
what is that?
-1, they would want it in like. Okay, wait. Can you explain how you got pi over 2?
Okay, so when you know it's -1, right? And
Mhm.
so when you go down here, it's -1. And then so this guy right here is if it's 1, this is 90, right? This guy right here. When you go this way, it's 90. But when you go this way, it's -90. It's pointing down. How how do you guys usually get it?
It would be negative pi over 2, right?
It is negative pi over 2, yeah. It's this
Okay.
guy.
Okay, yeah.
It's either negative pi over 2 or obviously you go all the way around, you could also do that. So
Mhm.
that's pi over 2, pi, 3 pi over 2. It's either 3 pi over 2 or negative pi over 2. If you, it's the same thing. If you go this way, it's negative pi over 2. But so you did get it right though, right?
Yeah.
Okay. As long as you memorize it, that's fine. Well, let's do this guy. So it's cotangent inverse. So when you do something like this, I would probably do like the tan, like 1 over arc tan. So 1 over arc tan of -1. And what did you get for this one?
It'd be tangent -1, right? So it would be
1
negative pi over 4.
and then inverse -1. Pi over 4.
Yeah, negative pi over 4.
And then so when you do this one, let's see. So this 1 over, yeah, negative, it's 45 degrees. So I would say, yeah, it's negative 45 degrees or negative pi over 4. And how you usually do that is just you go here and you create that 1 by 1 like triangle, I believe. So let's see, it's a negative 1, sine. So hold on, let me see. This tan is just the TOA, opposite over adjacent. Let me think. So that's negative 1. And that one. And this is negative 1, and then this is 1. And this is pi over 2. So this cosine one is if you did negative 1 over okay, I see. Yeah, that's the one. Yep, it's this guy. Because when you do this, you're gonna get negative 1. All right, let's see. All right, what about number 17? Do you remember what you got?
So the cosine of 2 pi over 3 is negative 1/2.
Yeah, so this is a double one, so you have to do the inside first. And
Yeah, so then the sine of negative 1/2 is negative pi over 6.
let's check that one. Negative pi over 6. So cosine of 2 pi. So that's going to be, so you have pi over 3 here, and then 2 pi over 3. And then so you go down, and this is 60. And then so this is root 3, and then 2, then 1. Okay. So the cosine for that would be 1 over 2. Yep. And then you said negative pi over 6, right?
Mm-hmm.
So this right here is the 1 over 2, so sine inverse of and here, let's say, what was it? That should be positive, okay. And let's take a look at that one.
Wait.
You said negative pi over 6?
Yeah.
It's negative 1/2. So this guy, because this is going to the left. Okay, that makes sense. Yep, it's negative pi over 6.
Okay.
Because this is going to the left.
And I think for 19, I remember getting pi over 6 again. I think it was positive this time.
You said positive. Okay, let's check. So
Or it might have been negative.
all right, so for this guy, let's see, so pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. And then, so this one is root 3. 1, this is negative, and this is 2. All right, so sine, opposite. So that's going to be negative 3 over 2. And what's the sine inverse of that guy? Let's take a look at that one. So square root. Oh wait, it's just doing the inverse, right?
Yeah.
So it should be the same guy.
Oh.
It should be the same guy because it's just doing the inverse, right? You have sine and sine, and you're doing the arc sine of it, or the sine inverse. They should cancel it. Either way, if you did 5 pi over 3 or negative pi over 3, or negative pi over 3, it should work. I mean, it's just the opposite way. You're going right. If you go counterclockwise, it's this guy. If you go clockwise, it'll be this guy.
Wait, really?
Does that make sense? How did you get it?
I found the sine of 5 pi over 3, and then.
Because if you do like sine inverse, it cancels the sine. It's pretty much an inverse.
Mm-hmm.
And when, like for some of these, I mean, like this guy obviously is different. I know this guy right here. It will cancel out. It should be -1. Whenever you see something like this and then like this guy.
Oh. Dang.
These are these are freebies for me. I mean, it's just you can either do it the way I did it or like memorize it. But
yeah.
The trick here is it's an inverse. It's the opposite of it. So it just cancels.
Oh, okay.
That's a shortcut, but that's just my theory because it's an inverse. Does that kind of make sense though?
Yeah.
Okay. Let's see. All right, let's do number 12. Do you remember what you got for that? Is 1 over root.
Is that just 1? Wait, no.
Tan inverse of 1 over root 3. It's a pi over 2. Oh, not pi over 2. It's a sum pi over 3 or pi over 6 term. Let me see. Arc tan 1 over root 3 degrees. What did you get?
What was it?
What did you get?
What did I get?
Yeah.
I don't really remember.
Okay, it's pi over 6.
Pi over 6.
Yeah. So let's see if I get the same thing. So this is 1 over pi over 3. So hypotenuse is, oh no, it's a tan. Oh, what am I thinking? So it's opposite over adjacent. So
would it be pi over yeah, it's pi over 6, right?
Yeah, 5 or 6, yeah.
Okay, then yeah, I did put that.
You got that one? Okay, good. So let's see. So 1 root 3. And then 2. 1 over root 3. And what is this? Since that's 1, then this is 30 degrees. This is an easy one. So yeah, 30 degrees. All right. What about 14?
So you just switch it, right? Secant
Yeah.
would be cosine of -1/2, which is just cosine of 1/2, wouldn't it?
So it's right? So cosine of 1/2?
Yeah.
What I usually do, so this is let me see, let me check first. So arc 1 over so instead of that, we secant hypotenuse over this guy. And so the hypotenuse is -2 and then a adjacent Where is that negative? The hypotenuse is never negative, so it's probably here. Let's see. It looks like it would be here. This is 2, negative 1, and root 3. So hypotenuse 2 over negative 1. Let me just check. And then this one is 2 pi over 3. Let's check. So secant, arcsecant in degrees. Yeah, I got it right. Did you get this?
What is it? 2 pi over 3?
120 degrees, yeah. 2 pi over 3, 120 degrees.
But okay, secant goes with cosine, right? So it'd be cosine of. But okay, so for cosine, doesn't it not change? If it's a negative, it still goes to positive?
You're applying that one? Yeah, I would probably, in my mind, like, don't apply that. Just, yeah, you're right. But the thing is, just read it the way you look over here, because when you graph it, you know what I did here? This negative sign is going to make a big difference. Because what if it's positive? Then it's going to be like pi over 3.
Mm-hmm.
But if you go along with whatever they give you here, negative 2, you need to go to the left side, which means this guy has to be 2 pi over 3. Does the way I'm doing it kind of like projects, like it's easy to see like, oh, okay, now it's 2 pi over 3. Okay. If how did you get, well, actually, like, how would you do this if you were doing it?
Like it'd
Circle.
be 1/2, so it'd be negative 1/2. So cosine of negative 1/2, but
Oh, I say so. Cosine. Oh, let me do that one. So cosine inverse of negative 1/2.
yeah, but cosine when it's if you like put the. Oh no, I think you're right. So it'd be 2 pi over 3.
Okay, so you corrected it. So that's good. Yeah, it's the way you're like, doing this way. I think it's fine. But you know how like you have the SOHCAHTOA, you could just switch how you read that, right?
Mm-hmm.
Like O or Ka can be SHA.
Mm-hmm.
So after I switch it to SHA, I will just graph it like this.
Yeah.
And you know, obviously since this is negative, the hypotenuse can't be negative. So what will result in a negative is going to the left. The
Mm-hmm.
adjacent to the left, not to the right.
Okay.
Does it make sense?
Yeah.
Okay. Yeah, like using the con and switching. I think that's the easiest way how I would attack it. Let's do number 16. So what is this? What counterpart is this? So this is
It'd be sine, right?
yeah. So and then it'll be co, right? And from this guy, let's see. So this is positive, right? So since this is positive, it has to be the opposite. Okay. Over here, let me think. 1/1. Let's just assume it's here. So 1/1, it says. So that can't be a pi over 2, 1.
Would it be pi over 4?
I think it's just this guy. Pi over 4, yeah. It'll be 1/91s. So let's see. For this one, arc cosecant of 1. Yep, this one's 90 degrees, yeah. It'll just be this guy,
Oh.
which is pi over 4, or pi over 2.
Really? So sine of 1 is pi over 2?
Yeah, it can't be pi over 4. I was thinking it was pi over 4 first,
But that's because that's a tangent. It's 1.
cosecant cosecant of 1, like our cosecant of 1 is 9 degrees. Let me try to explain this one. So let me see. So over here, because we're trying to get the hypotenuse to be 1, right? Yeah.
The hypotenuse to be 1?
Yeah. Because this is cosecant, right? And then like the opposite of it would be well, it's sine, so opposite over hypotenuse. And since it's cosecant, it'll be hypotenuse over opposite. So when is your hypotenuse ever 1? It can't be a pi over 4, right? Because the hypotenuse for pi over 4 is root 2, isn't it?
Yeah.
So it has to be one of these guys. So since it's positive, it has to go up. It can't go down. So that's the reason why.
Okay, but like it's just it's not on like the unit thing that we have, the unit circle thing that we copied. There's like
What does it say for yours?
I could send you a picture right now if you want.
I'll probably just look it up. It's a pretty common one. Is it unit circle?
It doesn't have like for sine of 1,
Yeah.
like there is no sine where it's just 1. There's only like the tangent where it's like 1.
Do you guys have the solution for this quiz by chance?
No, not yet.
I'm pretty sure it's pi over 2 though. Let me just see how to better explain that one. So let's see. The sine of 9 degrees is 1. I'm pretty sure. Cosine of 9 degrees is 0, right?
Mhm.
Because if you did this one,
Yeah.
oh right here.
Okay,
Well,
yeah, I understand.
what's the Okay, you got it now? Okay.
Yeah. It's just like they didn't write like for the what we copied, like we didn't like write the full things, if that makes sense. Like
Yeah, makes sense. Like the one thing is that's why I never rely on that unit circle.
mhm.
Because like if you draw, like when you draw these triangles, right? You'll see
Yeah.
that there is no hypotenuse that's 1. There isn't one, right? The only time it's gonna be 1 is here.
Mhm.
So I guess it's just a common sense thing. Like when you see 1 right here, yeah, it does make sense that like maybe tangent can be 1, but I think not at this point. I think because tangent is opposite over adjacent, right? Tangent is opposite over adjacent, so I think the only time a tangent will be 1 is when it's like root over 4 or pi over 4.
Mhm.
Is it? But along the pi over 2's or negative pi over 2's, those have to be cosines or sines.
Yeah. Okay.
Yeah. For tangent to be 1, it has to be like a pi over 4. Okay. This next one is pretty simple. We can skip this one. Let's look at 12. Oh, so this one, they did something menacing. They switched it. So let's see. So cosine inverse of 3 over 5. So this triangle is a common one. What was it 2, 3, 5, I think? 2, 2, 3, 5 triangle. I think that's what is it. 3, no, not 3, 3, 5. 3, 4, 5. 3, 4, 5 triangle. 3, 4, 5. And if I remember, okay, let's just draw it on. So What was cosine again?
For oh
Ka,
oh
right?
yeah.
Like it's also ka. So the top of the fraction here is your adjacent leg, and then the bottom is your hypotenuse. So let's just 3, 4, 5, and then so cosine of that guy. You remember what you got for this one?
No, not sure. Because I remember being confused and I was like, oh,
Okay.
that's a lot of work. Because wait, what are you supposed to do when it's like a number but it doesn't have pi in it?
You have to draw out the triangle. Yeah, for these ones, you have to draw out the
We
triangle.
don't do triangles.
You guys don't do the okay. So what I would probably do, like, but there's no like, you guys don't have calculators right during the exam. Yeah. What has what has the your teacher taught you guys when you don't have a pi inside the tan in, or the trig inverse functions? What have you guys
I'm
done?
not sure. I'm
Okay.
not sure. That's why I'm confused.
Okay.
Because I wasn't there for a day. But,
Okay. What I would probably do is because you don't have a calculator, which is always menacing, and this one is like definitely one of those like triangles, the 3, 4, 5 triangle is I would just draw it. And I think if I remember, you guys have to do like how do you get the other triangles? Let me see. Hmm. Cosine inverse. Because cosine inverse of this guy is going to be a decimal, which I don't know how you guys would like figure that out.
yeah, I don't, I don't know either.
Because yeah, the cosine inverse of this guy is like 53. I believe it's like 53.31. And then once you take the sine of that, there's like no way you can do that mentally. Hopefully she doesn't want you guys to remember like the actual, because if you look up like 3, 4, 5 triangle,
Mm-hmm.
like it doesn't change. Like you could have 3 times 2, 4 times 2, 5 times 2. It's just gonna be a multiple of 3, 4, 5. The angles for that they don't change. It's just the 3, 4, 5 try. Let me see the or you could apply the law of sines. Law of sines or law of cosines. Have you guys touched on those?
I don't
You don't
think,
remember? Okay.
I
Because
don't think so.
if you're given like 2 legs, or like all the legs in this case, you can get the angles by the legs. If you did, yeah, law of cosines. That would be missing. Okay, let me actually draw it. So you have to do this law of cosines in this case to get one of the angles. So that's 3. over 5, okay. Let's see if the math isn't that menacing. So a squared cosine of this angle right here. And this angle is the one opposite the longest leg. Let's see. So if you did this as your theta, so that's going to be a squared plus b squared minus c squared. And so this guy. Yeah, this is what you have to do, because you're given the 3 sides, and then like one of the angles is the one that you have to solve for. Let me just erase this first. All right, let's see. So when you're given this guy, 3, 4, 5, and then I want to know the theta opposite of 3. Let's just make this A, or A, small a, small b, small c. This is big A. Cosine of big A equals b squared plus c squared minus a squared divided by 2bc. Okay, do you see what I'm writing?
Yes.
Kind of, okay. So the law of cosines, you have to apply this. I'll just explain this like kind of, and we'll cover this again. The law of cosines, you apply it when you're given like three legs of your triangle. So in this case, you have 3 legs because of this guy. It's a 3 over 5, right?
Yeah.
So because it's 3 over 5, one of them has to be 4. It's just what it is, because it's a common triangle, 3, 4, 5. And since you have, so in my case, this is what I did. I made the small leg as small a, and then the longer leg as b, and then the hypotenuse as c. And then I want to solve for my interior angles. So whatever is opposite is going to be the capital letter. And I think you already have this guy. It has to be 90. So you just have to solve for a and b, or you just have to solve for a, and then you can get b from c. So if you solve for a, it's going to be cosine of A equals B squared plus C squared minus A squared over 2BC. And then since you have all of this guy, right, on the right side, you just have to take the cosine inverse. And you should get A. Does that make sense?
Can you put it in?
Okay, so let's see. Let's see what the value is. So B is 4 squared plus 5 squared minus 3 squared divided by 2 times B by 2 times 4 times 5. So that's 0.8. Okay, and then 0.8 times cosine inverse, or arc cosine of 0.8. How would okay, that seems like it's right. So let's see. So when you do that, you're gonna get cosine of A equals 0.8. But what is 0.8 though? Isn't it 4 over 5?
Yeah.
4 over 5. So cosine inverse. Probably have to do some like algebra inside here because so you have 4 over 5, and then you did cosine inverse of 4 over 5. Without a calculator, gives you that guy. Let me think. So and then B is 90 or minus cosine inverse of 4 over 5. Yeah, that should be like 180 minus 90 minus that guy. So it's 53.3. Hmm. Wait, cosine inverse. So if you get that one, and you get the sine, okay, I think I got it. Okay, so let's try to leave these guys. All right, so I think you have to do some like it's in essence like algebra. So when you do You remember like this thing, sine of A equals the square root of 1 minus cosine squared A. This is just an identity, right? Yeah.
Yeah.
So when you do that, the cosine of A is 3/5, right? In this case, if we make A the whatever that value might be. Yeah?
Mm-hmm.
Because of this guy, yeah? Does this one make sense right here?
Yeah, I think so.
Okay. So since you know cosine of A, it's 3/5. What is cosine squared of A?
Would it be 3 over 5 squared?
Yeah, so 9 over 25, right?
Okay.
So you do that, and then you just solve for, let me see if you can get this correctly. 1 minus 9 over 25. And so you're trying to solve for this guy, right? This is A. Yeah?
Mm-hmm.
Because A is what in this case? Cosine inverse of 3 over 5. I guess I have to do some algebra. And then you get this guy right here, right? For cosine of A. If you did cosine of this guy.
Mm-hmm.
And once you square it, you get this. And then you get this. And then this whole thing is equal sine A, which is what you're supposed to get, sine of A.
Mm-hmm.
And you just evaluate this guy. So 1 minus 9 over 25 is 4/5, right?
Mm-hmm.
This guy is 4 over 5. I know this one is a tough one because you have to do some algebra along with Trig.
4 over 5? Wait. Wouldn't it be 3
4
over
over 5.
9? How would 9 go into... How would 9
So
go into...
square root of 1 minus 9 over 25
Oh, the whole thing.
of the whole thing, yeah.
I don't think... I don't know how she would expect us to solve that in like 10 minutes.
It's the last problem. It's like one of the last problems, right? But like, let's go over that again because I don't know if you caught on to the steps, but you may have to do that for the exam.
I don't think so. We've like never done anything like that.
But let me just explain it just in case. Maybe if you have something, because this is just, maybe we'll cover something similar to this again next time because this is, I mean, it's nice, but it's really tough.
Like they had like answer choices, I think, but that wasn't
Okay.
5. It might have been on there.
So I guess the very first thing when you see something like this is make whatever's inside like a variable.
Yeah.
And then so you have sine of A. But then, so that's one variable, okay, you set that aside. So you take a look at what A is first. And then cosine inverse, 3 over 5, and then you take your cosine of this guy, right? Of everything.
Mm-hmm.
And then you get a cosine of A. Just to like summarize, if I can like write cosine of A, 3 over 5. And then you square this because of what you have here, because of the Trig identity. The sine squared plus cosine squared equals 1. And then so when you square this, you get this guy, and then like you get sine of A like algebraically in essence.
Yeah.
It's not bad if you went through the steps. If anything, I would probably do that last. Because
Yeah, definitely.
all the other ones, see, they don't even tell you, right? They don't tell you in here like do some algebra.
No.
Yeah. Okay. So the other ones you get though, right? Like 11 to
Yeah.
18 or 19. Yeah. And what about everything else in this sheet? I think there's the simplifying the trig functions. Do you guys have to do that using the identities?
That's the same as
I think Kind of like what I there. Let me show you something. Like this guy.
Oh,
Like
that one?
what if you had to simplify the left hand side to the right hand side?
Yeah, that one I think, can we do one? I think I pretty much understand that one.
Okay, let's just go over it because this guy actually has like nice stuff in it. So let's see. All right. So for this guy, you just have to know like all of them. You just have to know your trig identity.
Mm-hmm.
Let's try to find what this is. Tan squared x plus 1 equals secant squared x. Somewhere in here, yeah?
Mm-hmm.
It's this guy.
Mm-hmm.
So knowing that, you have to manipulate these to get like what you want. Sometimes it's given to you, which is good. So it's what you have here. So, and you have to take a look at what you can substitute for. So knowing that secant squared is this guy, substitute that in here. I guess I do have to write. So when you do this, tan squared x minus tan squared x plus 1 over cosine, right?
Mm-hmm.
Cosine of x. And how come it's, oh, okay, that's like this negative sign. And then, so this is negative actually. So minus tan x minus 1. The tan squared x's cancel. And you're left with this guy. Yeah.
Okay.
And then this is easy, right?
Mm-hmm.
Because it's just the reciprocal one. That's it, which is this guy.
Mm-hmm.
Okay. Let's try another one. These aren't hard, but you just have to know, like, it's pretty much like you apply your identities and you do some algebra.
Mm-hmm.
That's the rule of the game. So for this guy, tan of x plus secant x. Uh, if you don't see anything that can simplify for tans and secants, the rule is to always like simplify them to or like equalize them to their cosine sine counterparts. So for
Yeah.
this guy, you get tan x equals sine x over cosine x. This guy's 1 over cosine x. And then knowing this, you have to simplify it. What they mean by simplify is they always want it as one fraction. So you know how to do that, right? With this guy.
Yes, I know how to do that one.
Okay. And then when you have something like this, uh, in the same sense, try to let's see if we can. Oh, so they took the different route. Okay. I guess you could do it that way. The one thing is, let me think. Doesn't even look like it's simplified. That's the funny thing. Like they went from this guy to this guy. But like if you take a look at this, uh, let me think. Is it sine cube x? Is there an identity for that one? Or 1 over cosine. I just don't like how this doesn't even look like that
Yeah, I'm
much
like,
simplified.
wait, why did it? Normally, like, whenever we try to get, like, the final product, we want to just, like, sign.
Exactly, yeah. For the most part, this is a weird, sometimes you get something like this, probably not something you guys will encounter. Let's take a look at this guy. So this is kind of similar, get this guy in terms of cosine, and then let's see what he did here. Cosine, cosine, cosine. Okay, so cosine over cosine, and then cosine squared plus 1 over, yeah, this is simple, right?
Mm-hmm.
Okay. What about this one?
Cotangent x plus 1.
Oh, this one is just applying it. They gave you something that's already an identity.
Yeah, so it would just be, yeah, because you can't.
I remember when I was learning this, there was like a way to remember these guys, like a chat. I forgot what it was. Like
I actually,
sine. Yeah, I don't know if you guys learned it that way. Like tan squared plus secant, tan squared plus 1 equals secant. There was like a chant for that.
no.
The one way, the one like identity I know is only this number one right here. This is the simplest one. I always have
Mm-hmm.
to look at number 2 and 3. And But you guys have to memorize it though, yeah?
Yeah.
It's not bad. Just memorize one and try to manipulate it. That's like the game. All right. What about this guy?
Okay. Yeah,
So this
so
guy,
you would just decompose it all, or
yeah.
however. Yeah. And
So it's
then,
not bad, right? Like turn
yeah.
everything to like their basic forms of sines and cosines and simplify. Boom, 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 and 1 over cosine squared. And then you never want a radical if you or a rational if you don't need to. So turn it into secant. And then I guess secant, this is like going overboard. Secant, I would think this is the most simplified form.
Mm-hmm.
But I guess yeah, they did that, and then they wanted to. For you guys, like, so that is what you have to do. Like, you have to leave it in terms of cosine and sine.
Yeah.
Okay. What about this one?
Okay. Okay, so that's one of the tangent one is one of the reciprocal thingies. Yeah, the Pythagorean.
Yeah, the second one. And then so when you do that, you put secant here. And once you put secant there,
Can you
you
change? Yeah, you change from 1 over
this on,
cosine.
and then you have this squared thing. You could just do squared sine over cosine. Hold on, let me think. Why did
Wait,
they?
why?
What I would do, what I would do with this guy right here is
How
just
did
this.
cosine become squared? Oh wait, never mind. I get why. Because secant squared. Okay. Mm-hmm.
It's tan, supposedly. I don't know. Hold up, let me think. So, why isn't it just tangent squared?
Yeah. Why wouldn't it just be tangent?
Yeah, that's what I would think it would be.
And why would it be tan over cotangent? What?
Yeah, right? I think there's something wrong with this one. This is definitely the answer because once you get this, you
Mm-hmm.
can just transfer it to this guy and take out the squared.
Yeah.
Okay.
Okay. I think I'm pretty good at those. For the
Okay.
most part, I pretty much understand
For
those.
besides these two, see, yeah, like that's why I was looking at this. It doesn't seem like it's hard, but you can never be too complacent. Make sure you
Yeah.
start, you know? Like all of this, like make sure you do hard ones. We'll cover it on Wednesday. I guess some harder ones. These other guys, 2, 3, and 4. And besides these two, are there other questions you might like give you guys?
No. I think it's pretty much over just that.
That's what she told me. So like just to evaluate these at the inverse, and then
Mm-hmm.
simplify your trig
Yeah.
expressions using identities. Cool. Okay, I guess so for Wednesday we'll cover the challenging ones, and then like
Okay.
I did send you those, so try to do them ahead of time if you can.
Yes.
Yeah. Okay. On Wednesday, I forgot what time, but I'll send you the. I think it's about the same time, about 4 or
Okay.
5. Cool. All right. Have a good one.
Okay. Thank you. Bye.